here is our next round of just a little bit of help to get you through this project. You want to find the original that I sent out, the original document. It was an email. I wonder if I have it posted anymore. I might try and load it up to Blackboard again just so you can have this content. But this is the t-shirt data that I pulled up. And what you want to do is get a cost function based on this t-shirt, what it costs us to produce t-shirts. Now, we can look, of course, at going from various pieces 12 to 23 up to 1200 to 3000 in quantity, and we get this particular price per shirt. Well, we're ordering a lot of shirts, 25,000, so we want to get a better predictor. Plus, when we're talking about cost in a dynamic pricing culture where it all depends on how many units you want to sell or purchase, we want the function for cost. And so, like in class, what we're going to do is we're actually going to find the regression equation, the model for that cost that you see in the table. You can actually model that data table. And so I've got three options going. Your instructions are to go about this in a couple of ways. I think for the cost, I didn't specify how you'd model your cost. And so I just went up and just gave you some options. So here's what I'm suggesting. Everybody should take just the left-hand number in the pieces. It says a range of values, 12 to 23, 24 to 49. Just grab 12, 24, 50, and so on and put them in a spreadsheet. So you see them over here on the left. And I just labeled it pieces here up to 1200. And then the $3 or three color prices we're going for. We're going to go three color. So if you highlight those, you can do a model. I'm not going to go through those details again, but I have down here my graph of the data points. And then I did three models. I did a linear, quadratic, and a logarithmic. You can see those here. And I don't have the equation up there. I'll let you find that. But that's it. Or you can try something else. You can try a different model. You can do exponential. You can do a third-degree polynomial. Whatever works to get something that fits really well. Because your job is just to get that cost. And remember, cost is actually going to be, the function is going to be x times this regression equation that we just found. Cost, let's call it cost regression. Okay, that's what we want. Okay, that's going to be your cost function, so x times cost regression. That's just the cost portion of it, and of course you went and found revenue by taking the price regression equation of your choice. You did three of them. You did linear, quadratic, and logarithmic, and revenue was taking x times, so I'll type this up here. Your revenue was x times your price, your demand curve. We'll call it demand price, or price demand, okay? That was your revenue. And then profit is another thing you're going to come up with. And profit is, you take revenue minus cost. So whatever you get for this revenue function, there it is, minus whatever you get for your cost function. And there you have a profit function for which we can answer a whole bunch of questions. But that's the idea. This right here, this color multicolor table, is how you're going to go about getting this data here to do a scatter plot and a regression to get the cost regression. Don't forget to multiply that by the number of units, because what it is, the cost is a dollar amount times x means you get the cost to you for x units that you produce. Okay. All right, that's the end of the story.